We're now moving on to ratios, where ratios are a comparison of measured quantities. So these aren't necessarily comparing to the whole anymore, like we were seeing with proportions and percentages. This is a comparison of two quantities whose units are of the same type. We express ratios using a colon, which we read A to B. For example, a general guideline for making cocktails at home is to follow the ratio 2 to 1 to 1 for spirit to sweet to tart ingredients. Let's write a fraction to represent the relationship of spirit to tart as indicated by the ratio. So first, I'm going to write the spirit to tart is what I'm looking for. So that's the first and the third parts of our ratio. So writing that as a ratio 2 to 1 is our ratio for spirit to tart. Ratios can be written as fractions. So as you're looking at this, the 2 to 1 fraction for our ratio for spirit to tart, as you're looking at fractions, you really have to consider the context. Is this a proportion where the denominator is representing a whole? Or is this a ratio where the denominator is representing a part? So it can be confusing when you see these different fractions. Consider the context. The second part of this problem says if 4 ounces of spirit was used to mix a drink, how much of the tart ingredient would be required? So we know our ratio. I like to build this setup of my work to easily compare what I know the ratio for spirit to tart is, which we found 2 to 1 in our first half of the problem. But what we have is 4 ounces of spirit. So the question is, how much of the tart ingredient would be required? Well, if my ratio is 2 to 1 and I have 4 ounces of spirit to use, notice that I multiply by 2 to go from my ratio to what I have. So I want to follow that same process here and multiply the ratio for tart by 2 to figure out what I need to use. And in this case, 1 times 2 means I would need to use 2 ounces of the tart ingredient if I use 4 ounces of spirit in the mix. Another example of ratios. It was recently estimated that uninsured vehicles outnumber insured ones by about 6 to 5. So let's write that as a ratio to begin with. We have the ratio of uninsured vehicles to insured vehicles is about 6 uninsured vehicles to 5 insured vehicles. We know there are 2,002 vehicles in High Springs. How many of them are uninsured? So now we have a ratio that tells us 2 parts. The uninsured to insured are our parts. But we want to know how many specifically are uninsured. So we want to focus on a proportion from this ratio. In order to take this ratio to a proportion, we have to figure out the total that will go in the denominator of our proportion. So that's going to be 6 plus 5, which is 11. So our proportion of uninsured cars is going to be 6 over 11, the part over the whole. Now that we have this proportion from our ratio, we can take that proportion. We know 6/11 of the 2,002 cars in High Spring will be uninsured. Take all of our signifier words, turn it into an expression we can simplify. 6 over 11, of means multiply. 2002, so 6/11 times 2002 gives us approximately 1,092 uninsured cars in High Spring.